Five whys. Five whys or five whys is an iterative interrogative technique used to explore the cause and effect relationships underlying a particular problem. The primary goal of the technique is to determine the root cause of a defect or problem by repeating the question why. Each answer forms the basis of the next question. The 5 in the name derives from an anecdotal observation on the number of iterations needed to resolve the problem. Not all problems have a single root cause. If one wishes to uncover multiple root causes, the method must be repeated, asking a different sequence of questions each time. The method provides no hard and fast rules about what lines of questions to explore or how long to continue the search for additional root causes. Thus, even when the method is closely followed, the outcome still depends upon the knowledge and persistence of the people involved. Example. An example of a problem is the vehicle will not start. Why? The battery is dead. First why? Why? The alternator is not functioning. Second why? Why? The alternator belt has broken. Third why? Why? The alternator belt was well beyond its useful service life and not replaced. Fourth why? Why? The vehicle was not maintained according to the recommended service schedule. Fifth why? A root cause. The questioning for this example could be taken further to a sixth, seventh, or higher level, but 5 iterations of asking why is generally sufficient to get to a root cause. The key is to encourage the troubleshooter to avoid assumptions and logic traps and instead trace the chain of causality in direct increments from the effect through any layers of abstraction to a root cause that still has some connection to the original problem. Note that, in this example, the fifth why suggests a broken process or an alterable behavior, which is indicative of reaching the root cause level. The last answer points to a process. This is one of the most important aspects in the 5 why approach. The real root cause should point toward a process that is not working well or does not exist. Untrained facilitators will often observe that answers seem to point towards classical answers such as not enough time, not enough investments, or not enough manpower. These answers may be true, but they are out of our control. Therefore, instead of asking the question why, ask why did the process fail? History. The technique was originally developed by Sakichi Toyota and was used within the Toyota Motor Corporation during the evolution of its manufacturing methodologies. It is a critical component of problem-solving training delivered as part of the induction into the Toyota production system. The architect of the Toyota production system, Taiichi Ono, described the 5 whys method as the basis of Toyota's scientific approach. By repeating why 5 times, the nature of the problem as well as its solution becomes clear. The tool has seen widespread use beyond Toyota and is now used within Kaizen, lean manufacturing, and Six Sigma. The 5 whys were initially developed to understand why new product features or manufacturing techniques were needed, and was not developed for root cause analysis. In other companies, it appears in other forms. Under Ricardo Semler, Semco practices 3 whys and broadens the practice to cover goal setting and decision-making. Techniques. 2 primary techniques are used to perform a 5 whys analysis. The fishbone or Ishikawa diagram. A tabular format. These tools allow for analysis to be branched in order to provide multiple root causes. Rules of performing a 5 whys analysis. In order to carry out a 5 whys analysis properly, the following advice should be followed. It is necessary to engage the management in the 5 whys process in the company. For the analysis itself, consider what is the right working group. Also consider bringing in a facilitator for more difficult topics. Use paper or whiteboard instead of computers. Write down the problem and make sure that all people understand it. Distinguish causes from symptoms. Pay attention to the logic of cause and effect relationship. Make sure that root causes certainly led to the mistake by reversing the sentences created as a result of the analysis with the use of the expression and therefore. Try to make answers more precise. Look for the cause step by step. Don't jump to conclusions. Base our statements on facts and knowledge. Assess the process, not people. Never leave human error, workers' inattention, blame John, etc. as the root cause. Foster an atmosphere of trust and sincerity. Ask the question why until the root cause is determined, i.e., the cause the elimination of which will prevent the error from occurring again. When you form the answer to the question why, it should be from the customer's point of view. Criticism. The 5 whys have been criticized as a poor tool for root cause analysis. Terayuki Minura, former managing director of global purchasing for Toyota, criticizes them as being too basic a tool to analyze root causes to the depth that is needed to ensure that they are fixed. Reasons for this criticism include tendency for investigators to stop at symptoms rather than going on to lower-level root causes. Inability to go beyond the investigator's current knowledge. The investigator cannot find causes that they do not already know. Lack of support to help the investigator provide the right answer to why questions. Results are not repeatable. Different people using 5 whys come up with different causes for the same problem. Tendency to isolate a single root cause, whereas each question could elicit many different root causes. Dr. Alan J. Card also criticizes the 5 whys as a poor root cause analysis tool and suggests they be abandoned entirely. His reasoning also includes the artificial depth of the 5th why is unlikely to correlate with the root cause. The 5 whys is based on a misguided reuse of a strategy to understand why new features should be added to products, not a root cause analysis. To avoid these issues, Dr. Card suggests abandoning the 5 whys and instead use other root cause analysis tools such as fishbone or lovebug diagrams.